Let's look at running a hypothesis test for a population mean. And we're going to start with one where the standard deviation for the population is known. Remember, that's highly unlikely, but it's a perfect situation. Let's look at it anyway. Okay, so a study conducted in 2015 by a technology company, Rovi, now TiVo, showed that the average time spent per day browsing the video streaming service Netflix for something to watch was 19.3 minutes. Assume the standard deviation is 8. So this is a known value because they've studied the population. So this does make sense in this case. Suppose they take a simple random sample of 100 visits and the mean of the sample is 21.5. Now, a social scientist is interested to know whether the mean time browsing Netflix has increased. And we're going to use the level of significance, alpha, and that's an alpha, is at 0.05. So we're going to state the null hypothesis and the alternative, and we're going to do it in letters and words and numerically. So the null hypothesis is that nothing has changed, that the average time is still 19.3. In other words, the mean is still 19.3. The claim is that the average time increased. If it increased, it's greater than 19.3. Okay. So we need to check our conditions. We need to check to see if it's random, and then we need to check the size. So, is it random? Simple random sample. Yes. Size. Our n is 100, which is greater than 30, so check. Now we need to find our test statistic. So this is the process that we haven't done yet. So first off, we need to get our sample standard deviation. And this formula, we've been using it a while. We're going to take the standard deviation of the population divided by the square root of our sample size. And that one's kind of easy. That's 10. So 8 divided by 10 is 0.8. Now we're going to find the z-score for the sample mean. So here's the formula to find a z-score. The sample mean was 21.5 minus our claim divided by the sample standard deviation. And I know I've got a calculator around here somewhere. And I've got a little bit of a different calculator than most of you, but it'll still work. This is that NumWorks calculator. So I'm going to do 21.5. Oh, you can't see this very well. That's the good thing about the TI. Minus 19.3. Whoops. I have to do that. Then divide by 0.8. I got 2.75. Okay. Now we're going to do the rejection region method first. So I'm going to look at a distribution curve. So now this is a z-score. So I'm going to remind you that z-scores, oh, that's not how you spell scores. Z-scores have a mean of 0 and a standard deviation of 1. So 0, 1, 2, 3, -1, -2, -3. So 2.75 would be here. And we are doing a right tail test. greater than right tail. So we are wanting to find this area. We want to find the area. So to find the area, ignore this. We can either use the chart, that Z table, and look up 2.75 on the table, or you can go to the normal CDF on your TI, and we would put in the lower as 2.75, upper would be infinity, so we're going to put 1E99. We're going to use the mean of 0 and the standard deviation of 1. So I say rejection region. We're actually going to find the p-value. So I should change this. We're actually finding the p-value. This is not really the rejection method. This is actually the p-value method. The rejection region method would be a little bit different, and so I think this is the I'll show the rejection method on another problem. So when I do this, I'm going to get a value. This is the area right there, and it is 0.002979. Now what we're going to do is decide whether the result is statistically significant. So we're going to compare that to alpha. So we got a p-value. So we're doing the p-value is 0.002979. And we're comparing it to alpha, which was 0.05. It is definitely less than. If it is less than, we are going to reject the null hypothesis. So this is how we're going to answer the question. If we reject it, we're going to say there is sufficient evidence to conclude. If I am rejecting the null, then the alternative is true. So there is sufficient evidence to conclude that the average time browsing Netflix has increased. Now, if we were doing the rejection region, and we were doing a right tail test, right? Right tail test, right? Oh gosh. At a significance level of 0.05. We would compare our z-score with 1.645. This gets confusing. So the p-value method is a lot easier. I think so. Let's just use the p-value method is a lot easier to deal with. And you can also do this all using technology, so you really don't have to worry about a lot. So the TI-84 does this really nicely. And there's also an online calculator that I linked on Canvas that does it nicely as well. And I'm going to continue with the next example in another video.